So, two lectures tonight, two lectures today, however you want to think about it. A lot of coding today, though thankfully the coding is not super urgent in the sense that this first lecture, Exceptions, is all about iteration 3, so we're actually giving it to you way in advance. You don't need to worry about this until like week 8, so like 3 weeks away, quite a while. And the second lecture today is just useful in general throughout the course. So lots and lots and lots of fun stuff. This particular lecture called Exceptions, it's one of the last correctness lectures. You'll see that there's only 2 more correctness lectures, which is focused on like how do we try and make sure that our code works. We've been through the correctness bubble for quite a while, but the main motivation of today is that we need more elegant and graceful ways to deal with errors that makes our program more robust, because it's completely normal and expected that our programs have errors occur in them, but what we've been doing so far in the course with this whole kind of like return error objects and stuff like that, it's a very archaic C-style way of dealing with errors. So instead, we want to actually teach you a concept which is true, which exists in many languages, most of them, which are called exceptions. And for most of you, it would be the first time you've come across them. And then just how to deal with them, how to deal with raising or throwing and catching exceptions. So firstly, let's have a look at a fairly straightforward program. We have a program here called just crash, and what it does is it imports prompt from prompt sync. It creates a new prompt. You would have seen this from your labs. And then it has a square root function that takes in x, that's a number. If x is less than 0, we kind of print an error to the console, and then we exit the program, right? If x is not less than 0, we will return math.pow x to the power of a half, because x to the power of a half is a square root. Now, that's the square root function, and all the program does is it creates a variable called input. That's the result of calling prompt function, which prompts the user to enter a number on the command line, and then we console log the square root of the int of that number that's entered. So it's a relatively straightforward program. It's something that you should probably be more than equipped to deal with at this point in the course, right? Open this up. That's not what I wanted because we were working on assignment 2. Just close some of the old things. Yep. So I'm going to open up this just crash file, and we're going to use the file. Should be pretty simple. Just crash, easy. Then we'll run it. npm run ts node source/5.3 just crash. It should prompt us for a number. And if I enter, oop, what do we got? We got an error. Oops, sorry. Yep, I have to npm install stuff, I think. Let's see if prompt sync's actually installed. Maybe it's not. Oh, it's sort of installed, it looks like. Looks like I didn't install this in the actual lecture code repo. So I might need to install it. npm install prompt sync. There's this library here that it's like kind of installed. It's like half installed, but not really. It's installed like a types part of the library, which isn't really what we need, but that should install prompt sync now. Please enter number 5. Square root of 5 is 2.23. I'll try it again with a number like -9, and I get error input less than 0. So we have just console logged that to the terminal. Now, we have gone console.error. That does print it to standard error on the terminal, whereas console.log prints it to standard out. That's an important distinction in general, but not one that affects us too much right now. However, we don't always want to do things this way, and the main reason is because, well, it's not very good for the program to just crash randomly, right? That's generally not good program design. And you might be thinking, well, Hayden, it doesn't have to crash. I could actually just say return null in this case. And then when I get my input, I could say, you know what, if input equals null, then we will, then we'll console.error, number must be less than 0, or something like this, right? Like, you could do something like this. This works, but there are limitations to this approach. For instance, what happens if, now this function is returning like null or a number and a few other things. So from a type perspective, it can get tricky. What if null is a meaningful return value? So there are just some limitations to this approach. So What we prefer to do instead is to modify our syntax a little bit by doing what we call throwing an exception. Now the main line that's been modified here is line 6. So instead of doing console.error and process.exit or returning, some kind of object with null, we're actually going to throw a new error. I'm going to reiterate for the 6th time, like one of 6 times in this lecture, that this has nothing to do with iteration 2. It has nothing to do with lab 5. Okay? Please remember that. But this line here is very interesting. We're not going to get too much into this, you don't have to think too deeply about the syntax of throw new error, but it's self-explanatory. What it's saying is think of throw like scream or yell. It's like saying, or create, create and scream. We want you to create a new error and tell everyone that there's a problem here, run out of the building saying fire, 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 or something like that. And we're saying throw a new error that just says, that has the string error input less than 0. So create an error and scream it out to the top of the world. And what's interesting is that when we run this particular program, you'll notice that exception 1 pick a number 2, 1.41, right? That's easy enough. And then we pick another number, let's do -6. And we get this whole thing here. And pay attention to this. It says, okay, import blah blah blah. It said that there was an issue on this line, and this particular error object was thrown in the square root function, which is inside of a whole bunch of other really boring stuff. Basically, what it's saying is that the program crashed. So instead of ending it like we did in the first example, in this case we just threw an exception and it just crashed the program. And it might be kind of like, all right, well, what's the difference between those two things? They both seem to have exactly the same output. Well, let's take a step back and actually go and have a look at what this is before we get any deeper into the code, because it is a very different coding pattern that seems to do a similar thing. You notice we didn't have to return, where is it? What's it called? Exception 1. You notice we didn't have to return anything here. No one seemed to deal with the error explicitly, but it was still kind of handled. So yeah, let's look at some theory for a second. So exceptions. And what an exception is, what that line is, that throw new error, that is an exception. You are doing what you would call throwing an exception. That error thing is an exception. It is an action that disrupts the normal flow of the program. It's a way of kind of halting how things are going, and it tends to happen when an error occurs. So it's often representative of there being an error, typically to do with some kind of runtime error like user input or a bad network request or something like that. And exceptions are used so that we can elegantly recover from errors. That's why we use them. Exceptions are a particular method of ensuring that we can make software safer. And different languages, whether it's JavaScript, Python, Java, anything like that, they tend to have different conventions for managing unexpected runtime events. But while something like C and JavaScript differ quite a bit, many languages rely on exceptions for the majority of error handling, which is again very unlike C. Now, let me just check what. I think I might actually jump back to this slide after. Let's actually look at a bit more code first. When I ran this lecture last time, I think it was more beneficial to look at the code. And this is the code we saw before, right? Exception 1. This program is good in that it throws an exception, but the problem is when the exception was thrown, the program just crashed. Because when we deal with exceptions, we're not just interested in the throwing of exceptions, we're actually interested in the handling of them. And the handling of them is really what gives them, actual value here. So if we have this code, okay, we know it throws an exception, but let's actually add some more syntax to deal with the handling side of things. And this is where things actually start to get very, very interesting. So in this exception 2 case here, you'll notice the top half of the function from lines 1 to 9 is exactly the same, but from lines 11 through to 18, things are a little bit different. We've got this kind of funny little try catch block here. Now it looks a little bit like an if and else, doesn't it, right? Except it doesn't have a condition and it doesn't say if and else, it says try and catch. And this is a little bit of funny syntax, but what it actually says is it says, hey, I want you to run some code just like normal, right? So this try always gets executed. It's not like an if statement where it sometimes gets executed. It always gets executed. But what we're saying here is that any time, like anything you put in this try block you're asking JavaScript to keep an eye on in case it throws an exception. And if any of this code here on these 2 lines throws an exception, you immediately jump, wherever you're up to in the processing, jump to the catch part here. And the catch is essentially like how to deal with the problems. It's the block of how to, deal with the issues or the runtime anomalies that happened. And that's the usual typical flow. And then the code just kind of keeps going towards the end. So if you go through the try block and there aren't any issues, if there aren't any exceptions thrown in the functions that you're calling, then it actually just finishes the try block and jumps straight to the end, the done there. And we'll see this if I try and run this, right? If I try and run exception 2. Enter a number, 5. Okay, 2.23, it says done. That's good. But if I enter -5, I get, here we go, 0. Error when inputting. Error input less than 0. Okay. So a few things have happened here. There's actually been kind of 2 things. Oh, no, only 1 thing. Yep, sorry, I was misunderstanding that. So what's happened in this particular case is that it's gone through and it's executed these 2 lines, but an exception's been thrown on line 13. Now, what did I say before? I said that if an exception is thrown, basically if there's an error that occurs, we stop executing what we're up to. And the reason this is important is if I put, say, a console log here, and I run it with, say, a good number, like a 5, right? You'll see that it console logs the square root of the number, it console logs 3rd line, and then because there were no exceptions, it jumps immediately to the end. It skips the catch. But pay attention to what happens when I enter -5. Oops. -5 like that. You'll see that it immediately from here actually jumps straight to the catch. So once the square root's been called, it skips this line here on line 14 where console log 3rd line. And that's a really important other behavior for exceptions, and it's something that you can use to your advantage because you know this from iteration 1. If you have to return some kind of error object or error code, you have to put in a lot of extra checks in your code because let's say that the square root should fail at this point. You have to kind of go do a whole bunch of other stuff. And here's the benefit of exceptions, because imagine for a second that square root didn't actually throw an exception. What it did was it returned null if something was invalid. The problem with this is I would then need to refactor the code and go, well, you know what? The square root is this, and then I need to say, well, if square root equals null, then we're going to console log error. Otherwise, we're going to, print out square root. And it's just a little bit different. It's a little bit more regimented and structured, which some people would think is a good thing. Some people wouldn't think it's a good thing. But regardless, that's kind of where you get to here. Now, if we go back to the code, you will notice, though, that in the code we originally had in this file, what we actually did inside the catch statement was that if someone entered the wrong number or an invalid number, we actually went and prompted them again for another number. So let's imagine someone enters -5. They enter -5. An exception is thrown because we call the square root function, which throws an exception. That causes us to go in the catch, and then once we're in the catch, we say there was an error, we ask for a new number, and then we console log the square root of that new number. So now what we'll see happen is that when I go to run this, if I enter 6, it all works fine. And if I enter -6, it's going to go into the catch, and then it's going to say error when inputting, and then prompt me again. Enter another number, -9. But you'll see the program now ends because the program's just like a linear flow, right? It just goes from the start to the end. That's it. It's not particularly exciting. So you only really get 2 stabs at this. But if you want to take it even further, you do have something. Oh yeah, I'll get back to the error thing in a sec. You do have something like this, where what I'm now doing is just putting in a while loop. So let's say you want to kind of collect input from a user forever until they give you the right input, right? That's a pretty reasonable thing to want to do. So in this case, I say, well, success is false. While success is false, I want to try getting the input from the user. Then I want to try console logging the square root. And if at any point in this try there's an error, what it will do is it will skip line 16 and jump straight to the catch statement, and it'll print that out. So now we get a really interesting program which will essentially just kind of, you know, ask for errors all the time. Not ask for errors, like it'll keep going asking for numbers till it works. Enter number 3, that works, so the program ended because the loop left, right? Because when you get a number right, success is true. But if I do -3, it's like, sorry, that doesn't work. -4, -5, -9, -8, something like that, right? So that's kind of how we could use loops to say, keep collecting that information until we get something right. Now, just seeing what the difference is there. Yep. Now there was a good question which was like, what is error? So every time an exception is caught, we call it catching an exception. What happens is that original object that was thrown, right? Like you throw an exception and someone else catches it. It contained information, and we can actually console log that out. So let's actually console log error here. And what you can do is after the catch, again, a little bit like how an if statement is written, not how it behaves, you can actually kind of capture that in that variable there, just one. It's typically just one variable. And you'll see now when I do -5, oh, the program just crashed. That's not good. That's okay. Oops. Yeah, so what error is if I try this out? Oh, sorry, it was right there before. I just missed it. Let me put like pipes on it or something, just so you can see it a bit clearer. Yeah, so you see that entire error is actually an object, and it's an object with a whole bunch of stuff in it, because you can see these pipes here. And that whole object is honestly, it contains all the information about what error actually happened there. But on each of those, on every exception object, there's actually a property that I think is called message. It's different in every language, so I'm probably going to get it wrong. Yep, I probably... Oop. Oh, sorry, that was just the console log. Right. So if I try this now, now that's what I get. So that error input of less than 0 is the actual message that was given. So when you create an exception and throw it, there's a little string you can give it, and then someone else who's handling it can actually capture that string and just say, can you just actually print out what the error message is? I don't know what the error could be. It could be like 100 things. I didn't really write this part of the code. So very interesting, very powerful way of dealing with errors. That's honestly like a lot of what there is to it. When we look at the key points of exceptions, compared to kind of a C style, more like return null or return some object, key things are exceptions do carry data. That's really important because you can store lots of stuff in that object if you need to, like not just a string, but you could store other information. And then secondly, when exceptions are thrown, normal code execution stops. We already talked about this. What that means is that it's a little bit like an early return statement. When this throw is called, the code actually stops. And actually, technically what happens is that you know, you can kind of visualize your code as a series of functions calling functions, right? Like you have a main function that calls other functions, and those all call other functions, and it kind of ripples out like that. When an exception is thrown, what happens is all the program just kind of stops working for a second. Everyone stops, and that exception says, is anyone here to catch me? And if the answer is no, it kind of comes up to the function above and it asks that same question. And that's actually exactly why this square root function here, when we call square root and it throws the exception, we actually, you know, we look inside this function to say, is there anyone here to catch me? Because the exception was thrown on line 6. And if the answer is no, what it does is it kind of kills that function off, that function call, pops off the stack, so to speak, and then immediately comes up and starts looking for it in this function. And if there was no catch in this function, we'd have no idea what to do. So the try is really just a way of saying, this is the section where you should be aware that exceptions could be thrown, and then the catch is like, this is how you deal with those exceptions that could be thrown. Any questions on this so far? Because we're actually not far from the end. This lecture's fairly short. Let's take another example here. Try it out. What was this last one? 5.3 throw catch. Okay, maybe this one isn't too happy, but in this particular case, what we might be doing here is we might be, oh, it's the same thing, sorry. I thought it was to do with the parseInt. Same thing here, we have a program now, and this program is like, hey, if someone has 3 argvs, and remember 3 argvs is actually just one argument, because in JavaScript, if you look at argv, the first argv is actually kind of, is it argv? Actually, let me check that, sorry. I think I've gotten something slightly mixed up. Let's just print out process.argv and take a look. Yeah, so you got the binary you're running it with, which is TS node. You got the file name, and then after that, oh, that got removed. Maybe I have to make it a string. Maybe that's the problem. And that third argument, there's that there. Yeah, so there you go, not a number. So naturally, if I, for instance, put in -5 here, then -5 will get converted to an int. It'll get square rooted, and it should, square root should throw an exception, but it's not. That's really weird. Oops. I don't know. This particular program is actually just getting its input from argv on the command line. You don't actually have to do any standard input or anything like that. A little bit confused why that's not working. Strange that it's not picking up on more stuff. Maybe I did something wrong. Okay, seemed to like that, but not numbers. Okay, doesn't mind numbers, but not negative numbers. Very odd. It's probably something to do with something to do with the minus. Yeah, okay. Shell's a little bit weird. To pass in a negative number there, I had to add this double dash thing, but you can see in this particular case, it simply checks it. If the arg length's 3, it's like, okay, I have a parameter, tries to square root it. If it can't square root it, then just catches, the exception, does something like that with it. Fairly straightforward. I think that's mostly it. Honestly, the last slide is just this testing with exceptions, because what I did here was I created another piece of code called square root, like this, right? Very simple function, I just export it. So it's the square root function we've been using before, I'm just exporting it in this case. Except what I'm going to do is then test it. So I import the square root function, naturally. And then I go describe to check my square root's correctness, and then I've got 2 tests. The first one just deals with square root with positive numbers, right? So the square root of 4 should be 2, the square root of 2 should be close to 1.414213 to the nearest 5 decimal places, right? The second part here is kind of interesting though, but let's come back to that. So let's imagine for a second that I have those tests. So I'll go npm run jest on source 5.3 catch.test.ts. It's probably how I'm importing it, I'm guessing. Or maybe not. Oh, 5.3. Oh, I need to update that code. I think I moved a lecture around. Cool. So that passes, right? So it's very easy to write tests because you've written tests for iteration 1, you're writing tests for iteration 2, but one thing we haven't explored is how to write tests for exceptions. And what that means is that how do you test that when you call a function with a given value that it returns you an exception? Because remember, exceptions aren't return values. When an error is thrown, it's very different from a return value. Like exceptions are a whole system within a programming language. And this is how we do it. In this case, what we say is, well, you know what? I expect the square root of 2 when it's called to throw an error that has this string input, right? This is the error I want to get. And this one is a kind of an alias for it. These two lines do the same thing, like these two dot to throw error. But you know, we have the square root of -2 and we have square root of -5 there. Now this code will also work, and it should pass it because negative numbers do throw an exception, and those exceptions are those strings. However, right, what I want you to notice is how differently we have to operate with these. The temptation here is to do something like this, right? It's to say, well, I expect that the square root of -2 should throw that. But the problem with this is that what actually happens if this line was to get executed was that it tries to actually execute and call the square root of -2, which throws an exception which no one's catching, because what's actually happening here, I'll show you kind of what's happening. Imagine there's a function called expect, and what it does is it actually takes in a function. And then what it does is it says, you know, try catch or something like this. You know, and what it actually does is it just calls function within that. That's all it really does. So it kind of, that's why we actually give it a function. That's why we don't give it like because when I just write square root -2, I am not giving expect a function. I am giving it the result of a function that I called, right? So this one here gives expect a value, or at least tries to. This one here gives expect a function. If I give it the value, it's going to try and evaluate it immediately, which means expect won't have the time to actually like set it up and wrap it into something. So that's why I give it the function, because then what it does is it takes that function, it does something like this down here with it, it calls that function in a safe environment, it checks how it deals with it, and then it checks whether it throws or not, and that's where we get these nice little pieces of code. So this is something that you're going to have to do pretty extensively in iteration 3. Iteration 3 has just a couple of changes in it, nothing completely absurd, and certainly nothing as much as iteration 2. There you go. What do we got here? Oh, okay, it's just a colon issue, is it, or something? Yep. Oops, lost everything. 1 second. So this should now work for everything. Yeah, so 2 tests pass, right? So the way we deal with jest is actually remarkably similar. There's just slightly new syntax you need to be aware of about how to actually check whether exceptions are thrown. This also doesn't actually have a huge bearing on anything, because in your project you do a lot of stuff with Express. And with Express, you don't need to actually check for exceptions as much. We'll keep talking about that in the next couple of weeks, but that's not something you need to worry about. Do you have any, please leave some feedback. Do you have any other questions about this lecture for those who've hung around? It would be great to see if there are any lingering questions, because otherwise we will quickly move on. Jeremy asked a good question. So do we just chuck everything in the try catch? I like that question because it's very intuitive, right? Like Jeremy's kind of here being like, well, I get what you mean, Hayden, but, you know, why don't we just put everything in the try in case anything throws an exception? The short answer is that there's a couple things. One is it can make it harder for programmers to read. Like, for example, let's say, for example, that you had extra code like this. Like, you could put you couldn't put that there, but, let's say you had some other code like, getting started. You probably don't want to put that in the try because there's no need for it. Like, one thing is when you have a narrow try, you help signal to other programmers exactly what things could go wrong. Whereas here, it's like a lot of code. And also sometimes we actually have multiple tries. That's like another common thing that happens is that, let's say we do a different operation that could fail, right? That could throw an exception. Sometimes you'll just go and put that in a separate try catch because different errors sometimes you want to deal with differently. So it's not that you should always chuck everything in. If you're not sure, you can always put more stuff in, right? It's always safer to put more stuff in. But, right, that being said, be careful, right? Like, don't be reckless. Like, there's always ways to be lazy with programming, but sometimes we just want to, be a bit clearer to our colleagues and everything else. Yes. Have I been to the village green yet? Dylan says. No, I haven't. I have not. There was a LinkedIn update. I saw it yesterday, though. It looked good. These are all renders. There was actual photos of it. I lived next to the village green for 2 years when I lived at college a long time ago. So I've spent a lot of my life looking at that patch of grass. So I'm interested to see how it turned out. Yeah, no, I haven't. I'll have to check it out though. I think I'm on campus a couple of days next week. I think I'm there. Oh no, not a couple of days, just Tuesday. So I'll check it out on Tuesday, and I'll report. I'll take some selfies for people. Yeah. All right. I'll leave some feedback. I'm actually going to I'll take an early 5-minute break because we only have one lecture next and it's a bit longer. So we'll do an early break. So let's split for 5 minutes and keep going. Thank you, everyone.